So I hope I'm not talking to myself. Usually somebody says something, I'm not hearing anything or writing anything. So I'm wondering if this
Does
is
it have something to do with the inside square having odd sides?
simpler than that. Just look at what are the numbers that create new squares starting with 64? And for this algorithm, anyway, starting with 64, what do you see with the numbers that you're adding? 64, 144, 224. What do you see there that you don't see with 100, 196, and 36? Think about what,
four?
I'm sorry?
Is it just the number 4?
What do you mean by the number 4?
They're divisible by 4 as opposed to just 2.
Ah, but what else are they divisible by? You're on the right track. What is 64 divisible by that 36 isn't?
Eight.
Does that work? Look for the other numbers. Does that seem to hold? That's our theory.
Well, it divides into 144 as well.
Right, and it's not 244, that's a typo. What is that number supposed to be? This number right here is wrong. Oh, wait, I'm sorry, I'm assuming that you're looking at that. So if you look in the table, I can share it to show you what I mean. But if you're looking at the table, I have the last number is 244. What number should that be?
56.
256, yeah. So is that number divisible by 8?
Yes.
Okay, so we're thinking, okay, maybe if the square number that we're adding is divisible by 8, we're going to produce a new triple. That seems to be a good working assumption.
Mm-hmm.
Okay, and so when you look at these things, you start to see patterns. When you see patterns with whole numbers, that's number theory. You're trying to figure out why something happens, why this numerical pattern holds. So for the 256, for the 144, whenever we get a new triple that's divisible, when we used a square divisible by 8, it seems to produce a unique triple, one we haven't seen before, except for 16.
So every other squared even number will produce a new triple.
Yeah, every other square, every other even square is divisible by 8. So that means its square root is divisible by 4.
Yeah.
And notice that when that happens, when the number that we add, like 144, is divisible by 8, it seems that the pairs are odd. So you look at 144, 64, and even 16, what should be 256, and you see that the two highest members of the square are odd.
Because if they're odd, then it's guaranteed to be unique, because the fact that they're odd means they can't be divided by 2, and they differ by 2, which means they won't share any other divisors.
Exactly. Exactly. In order to have, if two numbers are 2 apart, they only have a common divisor if they're even. If they're odd, they can't have a common divisor. Because if you're 3 apart, the only common divisor can be 3, and so forth. So again, in presenting this, we're looking at the history. We're looking at like really early efforts at mathematics. The Greeks and the Pythagoreans in particular were thought to have been among the earliest people that really consciously and explicitly and communicated sort of the reasons why what they're looking, the reasons for the math that they're seeing. Like, I'm not saying Babylonians didn't know that why their formula for the quadratic worked. I'm sure they did know. It's just we have no evidence that they wrote it down or made a big deal of it. Maybe they were just happy that it worked. The Greeks, for whatever reason, seem to have been obsessed with trying to figure out why. And so when I do this, I'm thinking of the Pythagoreans about 550 BCE, and they're playing with the pebbles and they're saying, look, we can get these, they've proved the Pythagorean theorem, and they're saying, look, we can produce new triples by doing this kind of thing. And then they start to say, well, we saw that triple. We saw the triple 10, 24, 26 when we did the first algorithm, when we only added one row. Why is that? Oh, that's even numbers. And they have this doctrine of odd and even. Then they look at 144 and they say, oh, that's an odd number. Maybe, and they start to reason why these things work. At least that's sort of the assumption that most people who study history of math go by. And so my point in doing this is sort of to show you and getting you involved in this, because if you start asking these questions, if you've got math in your soul and you start doing these things and looking at, you start to see patterns. It's like in our blood. And so again, and for some reason the Pythagoreans were amongst the earliest to start saying, well, what's going on with these patterns? And I was hoping that you would, get involved in some of that thought, like trying to figure out what the patterns are. I'm not going to go and figure out why divisibility by 8 matters. We'll do that in another format at some other time, if you catch my drift. Okay. So that's what I wanted to do, and I was hoping to end class last week with that, and I'm sorry that I didn't get the chance to do it. So any questions about this? I didn't write anything down, but I can write some things down if that would be helpful. But the key, I will write that, the key for the second algorithm is that if 8 divides the square, then we get a unique triple. And that triple is going to be of this form. It's going to have that even square that we added, odd, and then an odd plus 2. And because that's odd, they have no common factor. 2 consecutive odd numbers can't have a common factor. Okay. So why this happens? Figure it out. Think about it. Okay. Okay. So before we leave this, anything else? I was going to start talking about the projects and put you into groups. Okay. And I'll fix this so it says 256, not 244. Okay. Okay, good. So for the projects, that's all we're going to do the rest of the day. So I'll spend about 15 minutes with each group. I'm going to start with the 4th group because I started with the first one last time, and the 4th group had to stick around for a long time. And what I'm hoping we'll do in these sessions, and what I'll hope you do in the rest of the time, that's why I'm doing it during class, is start talking about what you're going to do, and you can ask me questions. I'll try to visit each group a couple of times so we can do that. What I would like is for you to go to Blackboard and join your groups within Blackboard and start an ultra session. It's going to be much easier for me to form the groups, and I can also bounce around from group to group that way. And I think it's easier for you to communicate to me if you have a question or something like that. So let's try that and see how it works. Is that okay?
Sounds good to me.
Okay. Okay, so I'll leave this open for a little bit, and then in case there's questions, but go and log on to Blackboard and get into the groups, and then I'll join you there. And if you have questions about that, I can, I'm pretty sure you've got this figured out. Okay.
not really.
Good.
Okay.
I'm still stuck on some question actually. Wait, let's see.
You're stuck on a question?